Hi. In this video, let us take what we have done with the input manager so far. I was just using this input manager class, quote unquote, to show you guys how the new input system is working. So we looked at a way we could debug.log some things and see when certain values are being used, and we use it as a test for that. So before we work on our character, let's just convert this input manager class into what is more of like a usable class that our character can actually use. The idea here is that rather than our character class having, these different input actions in it, it's just going to have a reference to the input manager, and the input manager is going to be the one telling it which buttons were pressed when it was pressed. So, for example, this move input here, our character class is just going to read the move input value and we can use it. And it is the input manager that's actually going to have this callback context function that's going to read the input from the controller. So the input manager going to manage the inputs, pass it along to the other classes that need it. If anyone needs to read the input, they just get a reference to the input manager class. This is a good way to go about these things. I know in this class we are just going to be working on a single character, but if we wanted to have multiple different types of character classes, well, instead of rewriting the input code in each one of them, there's a single manager that helps maintain all of it. There are some other reasons which we're not going to go into in this class, but this is a good way to design it, where we have a single input manager and that can pass the input on to different classes that request it. So to start, let's just delete everything. We don't need this update function. And let's just figure out a way that we can have our other class. So imagine our character controller class. It wants to read the move input. How could we do that? There's a few ways, right? We could make the move input itself public. And this way the input, or our character controller class, can just read it. They can just say input manager dot move input, and that way they can read it. But this isn't ideal, because if it is public, that means they can also set it. So some other class could, say move input equals something else, and we don't want that. Move input should only change based on our inputs. So public isn't ideal. The other way, I'm just going to leave it for public now, is I could make a function. I could say void get move input. It wouldn't even be void. It would be vector2 get input. And all this function would do is return move input. And this is honestly a better way of doing it, right? That way this could say private, and we would have to use this different function called get move input, and that would return move input. Well, turns out this is such a common thing to do. It's called getter and setter. So a variable can have a getter and a setter. A getter will get the variable. A setter will set the variable. This lets us do these things in a controlled manner. And this is such a common thing that C# has kind of a shorthand for it. So what I can do is, after my variable initialization, or I'm sorry, my variable creation, I could just make curly braces, type get, semicolon, set, semicolon. And so this is telling, this is the same. This get here is the same as having a function called move input that gets it, or a function called move input, with the equals to. We can set it to something else. I don't want anyone to be able to set my variable, so I can make just the setter private. And so by doing this, what we have done is we have made a vector2 that has a public getter, because the variable itself is public, which means anyone can read it. But we've made sure to tell, in our code that only the setting is private. So we can only set it in our own class. Nobody else can set it. So this way it keeps it so it's readable, not writable. And this way our character controller can have access to this variable without, again, anyone being able to set it or mess it up, because we don't want that. So I'll go ahead and do these same things. So I'll make a Boolean for our jump input. I will call it jump input. And do the exact same thing. I'll make a get and a private set. Same thing for our sprint input. A get and a private set. Okay, so now we have some variables here that any class can read from the input manager, and these will contain the inputs. So just like we did for our onMove here, where onMove, we set the move input to the context, like the value of it. We need to create functions for our jump and our sprint. So I will I won't delete it, but I'll comment out this debug log because I don't want it there. But commenting it out also helps us, so later we don't have to rewrite it if something goes wrong. And I'm just going to make two more functions on jump and make sure to give it input action dot callback context. We'll fill it out up in a bit, and we'll do void on sprint, same thing, input action dot callback context. So one important thing is with this callback context, unfortunately, even though I told you that, a button press, we read it as a Boolean, a true or a false, we can't do context dot read value bool here. That's just not allowed. It's going to throw an error. We can only have it be a float. That's the closest thing we can use. So really, if this float was equal to 0, we know it's false. If this float was equal to 1, we know it's true. So we could hypothetically write something like, if the value of the button equals 0, then jump input equals false. Else if the context.read value was true, or greater than 0, it could be true. That's a little wordy, that's too much. So we could also change that to be, if the jump input float was greater than 0, it's equal to true. Otherwise, if it's anything less than 0, it's equal to false. So now we have if the if the button input is greater than 0, so if it's anything but 0, it's true. If it's not anything but 0, so if it's 0 or less than 0, which it won't be, but if it's that, it's going to be false. There is a shorthand to write this using something called the ternary operator, and I'm just going to show you guys that. So instead of writing it out as an if or else statement, we can just set jump input equal to, and then first we write the condition, that if condition we have up there, first we write that. So context dot read value float, and then we put a question mark, and after this question mark we write the true value first. So I didn't put the condition completely, so if it's greater than 0, so if the button value is greater than 0, we put the true value first, which is going to be true, colon, we put the false value. And I don't need any of this. But this and that if-else statement, they're the same thing. This just reads as set jump input to true if the button was greater than 0, otherwise set it to false. So it's just, and again, it's an if-else statement. This is just a nice simple one line for that. Going to do the same thing for sprint. So sprint input equals context dot read value float is greater than 0. If it is, it's true. Otherwise, it's false. And so, just rather than having if else, we've kind of condensed that into a nice single statement. Is a very nice piece of syntax that most modern coding languages have. Lastly, we also need to do the same thing we did here, where we actually subscribe our functions to these input actions. So we will have jump action dot performed on jump. Same thing for jump action dot canceled. Sprint action as well. And lastly, just as a piece of good programming, imagine if we have an input manager, it's activated, it subscribes to these functions, and then we remove our character controller. So this class gets destroyed. Well, these functions are still technically subscribed to the events, And it's good practice for us just to clean that up. So when our input manager gets destroyed or disabled or whatever, we want to unsubscribe these functions. So we can use Unity has some mono behavior has some built-in functions for that. There's on disable, for example, and on destroy. Because I'm calling these on start, on destroy makes sense as the counter function to that. If I did all this on enable, which is another function we have, then on disable would make sense to destroy them then. So on destroy, all I want to do is copy these and change these pluses to minuses. So here this plus equal to is telling us we're adding it. This minus equal to is doing the exact opposite. It's just removing it. And there you go. That is basically the input manager class as we are going to use it. And we'll make use of it in the next video. So thank you for watching.